Hello everyone, and thanks for joining us today. My name is Rob and I'm here at Genovis in Sweden, and we have a new product launch for you today. I'm soon going to be joined by Dan Back-Christensen from Symphogen, but before that I'm going to give you a brief introduction to the new product. So without further ado, let's get started. So we all know that biopharmaceutical molecules or biologics are large and complex molecules. They are difficult to characterize and they undergo post-translational modifications throughout the process of their development. That needs to be analyzed, and often we would use, for example, an LC-MS instrument. But prior to that, we need to prepare the samples in a specific way. This creates quite a challenge, both the sample preparation and the LC-MS step. And yet we have a considerable number of samples coming in from the different parts of the project. So for example, clone selection, process development, stability studies, and batch release. And then after that, we would look at the critical quality attributes like glycosylation and oxidation. So of course, if we could process more samples, then we certainly would. So what we've tried to do with what we're presenting today is to speed up and simplify the sample preparation step. So there's a number of different ways that we can analyze our biopharmaceutical molecule. First of all, we can look at the intact molecule, or we can do a peptide map using trypsin. Both of these have advantages and disadvantages, but a complementary way to do this is to do the middle level approach or middle level analysis of the antibody. And here we take a rather specific enzyme, we cut the antibody into smaller pieces, and we can then simplify and reduce the time of the whole process. And here you can see a comparison for an enzyme called FabRICATOR compared to tryptic mapping. So FabRICATOR then is one of our favorite cysteine proteases. It's actually an enzyme that we find in a pathogen in our throats, and it's a rather special enzyme. It's very specific and it recognizes the structure of the IgG, and it binds and it makes one single digestion just below the hinge in the antibody. So because it's so specific, we don't get any overdigestion and we do not need to optimize either. It's specific for human IgG 1 through 4, and it's a relatively quick reaction as well, so 30 minutes at 37 degrees, and it's compatible with a wide range of buffers. So it can be a truly platform approach. And as you can see here in the schematic flow of the digestion, first of all we add FabRICATOR to generate Fab'2 and Fc half subunits. And then with an additional reduction step, we go down to the slightly smaller subunits of FD, LC, and Fc half. And these are really ideal for LC-MS experiments. So with the new product, what we did was we immobilized FabRICATOR on agarose magnetic beads. And we did this because we wanted to make it more straightforward to do a middle level experiment. We wanted to automate the workflow. We also wanted it to be compatible with automation platforms in order to create a high throughput way of screening multiple antibodies in parallel. We wanted this to be fast, so 10 to 20 minutes, and we also wanted to make it rather straightforward, so a single pipetting step to get started. So we've been able to achieve this with FabRICATOR Magic, as we call it. And here we can see now our comparison of the new product, FabRICATOR Magic, with the earlier FabRICATOR workflow I showed you. And here you can start to see the benefits. So we're able to process multiple subunits or multiple antibodies in parallel. That allows us to reduce the experimental time. It makes it quicker to do the analysis. We have less user interactions with the experiment, so therefore we reduce the risk of sample handling errors, and we're increasing the capacity as we intended to do. So as I mentioned, we wanted to make this compatible with automation systems, but of course not all labs have accessibility to expensive robots. So we therefore have an optimized protocol for FabRICATOR Magic on the shaking table. So even if you don't have an instrumental robot that you can automate on, you can still use this enzyme on magnetic beads. We also, though, optimized the protocol for the Kingfisher, which is a small, compact benchtop instrument from Thermo Fisher, which is ideal for being able to handle magnetic beads. And this works on the principle that magnetic probes move down into the wells of a deep well block and are able to then move the magnetic beads around. And this is done in combination with a comb. And the comb is actually to keep the magnetic probes away from the sample, but also to allow for mixing, for example. So as you see in the schematic here, on the left-hand side, we first of all equilibrate the magnetic beads. We can then move the magnetic beads into a well containing the sample. We use the comb to mix up and down. The digestion takes place, and then we can remove the beads again using the magnetic probe. We're then left with our fresh processed sample in the deep well block, which is ready to be moved directly to the auto sampler of the LCMS instrument. So it's extremely straightforward and convenient. So by doing this, we're able to process from 12 up to 96 samples in parallel, or even multiple plates in parallel using the bigger Kingfisher instrument. We can do this very quickly as well, so we have complete digestion in 10 to 20 minutes. And as I mentioned, it's very straightforward just to then move the sample plate to the LCMS instrument. So, of course, we wanted to test out the product and really see that it worked to our specifications and could deliver what we wanted it to. So we decided that that would be best done in the hands of an expert. And we selected Dan Bach Christensen and his lab at Symfogen in Copenhagen to take the product and put it through its paces and have a look how it worked in their hands, because they're having multiple different types of antibodies on a routine basis. So with that, I'm going to invite Dan to join me here, and he's going to present his data using FabRICATOR Magic.
Thank you, Rob, and thank you for having me here. It's a pleasure. And I'll just quickly mention Symfogen, the company I come from. We are based just outside Copenhagen in Denmark, and I work as a principal scientist there. Our primary focus is antibodies and antibody mixtures against cancer. So the platform we've been using for a while now for peptide map type working is the Kingfisher that Rob just mentioned. And I've really been requesting and looking forward to the FabRICATOR in this format, because the subunit workflow is an essential part of our antibody characterization platform. So what we're doing here is that the important point here is that you take your sample and you place it in your 96 well plate. That is the only time you handle the sample. The rest is done by the robot, so you're perfectly in control of temperature and time, and it basically frees up resources in the lab because everything is done by a robot. And what we did here was then we tested the FabRICATOR Magic using our platform, and the evaluation was done by native size exclusion mass spectrometry as well as by reverse phase mass spectrometry. We did this on a Thermo Scientific Explorers instrument, and data evaluation was done in Chromeleon and using Protein Metrics BIOS software. So this is an example of a SEC UV trace, and here you can clearly see that without the FabRICATOR, we get a distinct monomeric peak that you typically see in a size exclusion separation. And when you add the FabRICATOR, we get a beautiful separation into two peaks, and those are the Fab and the FC part of your antibody. And of course, because we have a mass spectrometer hooked up, we can confirm everything by mass spectrometry readouts. A little curiosity is that the FC likes to stick together, and because we're doing native MS here, we actually see that the main form is the 50, the dimeric form of the FC. But that's a consequence of doing native MS. And so this is a very powerful platform for monitoring enzymatic activity. In this case, it's also our primary workhorse when we do ID testing, when we do lead selection studies on a larger number of samples. Okay, so here you can see we've taken a partially digested sample just to illustrate how well the IgG and the Fab2 are resolved. And from these peaks, we can get the mass spectra, and then we can do a relative quantitation based on the MS intensity. And that is what I've shown here. We basically threw the magnetic FabRICATOR MagIC towards 12 of our antibodies, some mixed products, some single antibodies, both IgG1 and IgG2. And the conclusion is clearly that this is a very active enzyme, and it works across a broad range of our products. So then we switch to reverse phase-based separation. And the aim here is more to look into quality attributes, and again also see what we can pick up in terms. There will be a case study very soon where I see where you can actually, how you can apply this technology. So the top rows, we have two different antibodies here, and in the top spectra you can see without any FabRICATOR. Once we add the FabRICATOR, we get the Fab2 peaks and we get the FC. And now a really nice feature, if you want to do a reduced subunit analysis, you simply add your reductant TCEP during the digestion. So it's not an additional step, it's just part of your digestion procedure. So the time it takes to get a reduced subunit sample and just a subunit sample is exactly the same. And then that's what you see here at the lower spectra. Once we do the reduction, we get the LC and the FD prime, and of course we still have the FC. So it's a very powerful workflow for getting all the information you need in a single sample preparation run. And here, these are just examples of the masses. You can see the intact around 150, Fab2 around 98 kilodalton, FD prime around 25, LC around 23. So because we have the MS readout, we are very confident that this is a very effective way of preparing your sample. So moving on to a case study. This was a mixed antibody product containing 6 antibodies. And we could see in one of our stability studies that we were losing signal for one of the antibodies. And here you can see the UV trace for the intact antibodies. Now we then wanted to understand better what is actually happening to this antibody 5. So we did the subunit analysis, and that is what you see here. Again, we see a large drop in antibody 5. So this confirms that the modification is sitting in the Fab2 domain. We then took the same sample and did the reducing subunit analysis, and this is what we get here. Of course, now things start to get complicated because you have 6 antibodies producing each an FD prime and LC, and then you have the FC. So you end up with a total of 13 species in theory, and we could actually assign them all as shown here. And again, now we see that for antibody 5, it's actually the FD prime region that's responsible for the drop. And if we kind of map out stuff that increases in the stability sample, we can see that the MAP5 FD prime region has a mass, a species that increases by 14 Dalton, and another minor species that increases by 23. And that's not quite oxidation. That would be plus 16 and plus 32. But we managed to pinpoint that this was actually a tryptophan oxidation, a so-called oxolactone, where you get the oxidation and then introduction of double bonds, which means you're losing hydrogen atoms. So you get a shift of 14 instead of 16, and this is beautifully picked up by our reduced subunit analysis. We can also see some other stuff going on here. We can see that there's an isomeric species for MAP3 light chain that increases. We see a succinimide form of MAP5 light chain. But really the main degradant responsible for the drop in MAP5 at the intact level is this oxidation that we see in the FD prime region. So a very powerful platform for pinpointing where your modification is taking place and what kind of modification you're dealing with. So this is just a zoom of some of the species, degradation species that we identified, and this is just to illustrate again the power of having the subunit analysis combined with a reverse phase MS readout. You can really pinpoint, you can see a mass shift from 670 up to 648, that's 14 Dalton. And for the last peak, you see 699, so a shift of 29 Dalton. So you get a really precise and informative information when doing these kind of subunit and reduced subunit analysis. So just to summarize, we've shown that the FabRICATOR MagIC is a very effective enzyme. And again, I have to emphasize that this is very much a hands-off approach. You place your sample in your 96 well plate. That is the only time or the last time you handle the sample. Everything else is done by the robot. And then you take that physical plate and put it directly in your LC or whatever you're doing. So there's really no sample handling, no pipetting. All the steps are done by the robot. So it's a highly automated process that's really frees up time in the lab and just increases the robustness of your entire workflow. Yeah, and then digestion can be done in less than 30 minutes, as Rob already showed. So it's short analysis time, it's fast, and it's hands-off. And I showed you some example of how we were able to map out modifications using this subunit and reduced subunit approach. And I think that's it for me.
Good. Thank you very much, Dan. We really appreciate all your efforts with this. You've done a fantastic job with this analysis. Thanks for providing us with the data and coming here today to present. Before you go, we had a couple of questions for you. And the first one relates to the specificity of magnetic FabRICATOR and whether you see any unspecific digestion.
No, I mean, we've been using FabRICATOR for many years, and non-specific digestion is not an issue. It's the same with the new product, so it's not a source of concern at all for us.
Okay, that's good to hear. And then we were also interested in your hands, using your types of samples, what CQAs, other than the ones you presented today, you might start to look at using FabRICATOR MagIC.
Yeah, of course, we have a broad range of quality attributes that we need to monitor. We usually determine how an antibody tends to break down before we develop it. So we do some developability assessments. Mm-hmm. There we would look at stuff like deamidation, oxidation, of course, which I showed, fragmentation, all types of chemical modification. Glycosylation is typically a part of the clone selection process, but also something we look for during lead selection to not to end up with something that's completely out of the ordinary.
Yeah. Okay, that's great. Interesting to hear. And then the last question that I had was around QC and whether you could envision this FabRICATOR MagIC being useful in the QC environment in the automation side.
Yeah, definitely. I guess from a broader perspective, I definitely see MS going into QC in general, and that needs to be supported by, solid sample prep workflows. And the FabRICATOR MagIC is completely hands-off. Everything is done by our robots, and so there's no manual steps once you've delivered your sample. So that's of course very amenable to a QC environment, say compared to a workflow where you would have more manual steps. So yeah, it's pretty much optimal for moving in that direction.
Okay, good. All right. Thank you very much. Thanks again, Dan, for coming over today.
Thanks
and for all your
having me.
efforts. We really appreciate it. And with that, then I would also like to thank you for listening. I hope you've enjoyed this presentation of our new product, FabRICATOR Magic. Of course, if you have any questions or would like to know more, then feel free to contact me at Genovis. Here you can see the web address, genovis.com. There's plenty of information on the website, or come in contact with one of us, one of the members of the team, and we'd be happy to help you. Thank you.